Now, tomorrow on the quiz, the whole concept over it is understanding how the ratios work. Excuse me. When we first started, we looked at the ratios between the legs. Remember, ratio means when you're comparing two things. So if I'm looking at this angle, which has the symbol theta on it, and I look at BC compared to BA, if this triangle is similar to another triangle, now that doesn't mean it's the same. Similarity means it has the same angle measures, but they're different sizes. It's the same shape. If I compare the ratios of this triangle with the same sides of this one, then what I'm looking at should equal. So if I call this opposite over hypotenuse and compare it to the opposite over the hypotenuse here, they're always going to be the same. So then we looked at, this is called the sine function. We have adjacent over hypotenuse, this is called the cosine function. If I have opposite over adjacent, this is the tan function, or SOHCAHTOA. But it's all about the ratios. Okay? These are all ratios.
Why is there no number?
We don't need a number. We just need to understand that the ratio is the same. If I do opposite, let's say there is a number, and this is 2 over 4. Okay? And this one over here is 8 over 16. Because it's bigger, it's going to have longer sides. But when I reduce both of them, they both become 1/2. They're still the same. So when I compare one leg to another, that ratio is always going to be the same when it's reduced. That's what this means. I don't need a number. I just need to know that when I compare the legs, they're the same. I could say sine of theta equals BC over BA. That's what we've been doing. I could say sine of theta equals EF over ED. Same thing here. It all works back into the same thing, and that's how the ratios work. Okay? No matter what the size, that's how sine works. So you have to have a basic understanding of that when we're working the problems. No matter what size, as long as they're similar, the ratios are always going to be the same. Okay? Now, the type of questions you're going to have tomorrow, they're not going to be a standard triangle with a missing side. It's going to be in application. The whole reason that we're doing this is to apply it to different situations, not just a standard problem. Now, this is a long paragraph, but I'll tell you the first 3 sentences have nothing to do with the problem. When you take the ACT to Aspire, it's going to be the same way. For driving safety, it's important for a driver to think about how far the car will travel by the time they finish a maneuver. Suppose the car is moving forward in a straight path. To change lanes, the driver must turn the steering wheel slightly. Common sense. This causes the car to travel in a direction that points 2.1 degrees away from the forward direction. So here's where I start. I'm going to start angling the car 2.1 degrees down and start changing lanes. Once the lane change is complete, the driver turns the steering wheel so the car moves forward again. If the lane on the highway is 12 feet wide, how far forward will the car travel to be able to change lanes? Now, it's hard to see that in the way it's presented. So how can we change that? How can we change the way it looks to make it something familiar? Okay, so which triangle do we... I can kind of see 2 triangles. I need to decide which one I'm going to go with.
The one that has the angle to the bottom.
Has 2.1.
Well, this one has an angle here, and then this bottom one has an angle here. Which one do you want to use?
The bottom one.
Oh no, I'm hearing two.
The bottom one.
Doesn't matter.
Yes.
Let's see.
Yes.
Let's pick out. I'll do both. Okay. We'll do a comparison. So I'm just going to redraw this triangle. So that's exactly what I have. How long is the width? 12 feet. This angle is 87.9 degrees. That's exactly what's written. What I'm looking for is the horizontal distance, where it travels from here to here. Do I know how to solve this problem?
Yes.
So what do I do first?
Find the thingies.
Find the hypotenuse,
Adjacent
find the opposite.
and adjacent.
Then after you're done, you circle what you have.
It's a T. It's a
So if I have adjacent and opposite, SOHCAHTOA,
tan.
this is a tan problem. Tangent of the angle, 87.9 equals the opposite over adjacent. When I have the variable in the numerator,
You multiply
I multiply both sides
by 10, 12.
by 12. And so what I have is 12 tan 87.9 equals x. So 12 tan 87.9. Now, on tomorrow's problems, you're just going to round to the nearest unit. You're not going to put any decimals down for answers. So in this case, it's 327.2. So I'm just going to make it 327. And it's very important that you put what unit it is.
Feet. But are we gonna have to draw our own pictures, or the pictures are gonna be drawn?
You're going to have one where the picture is here, but you're probably going to, it says show or explain your work. I'm not doing any explanations, but I'm showing my work. Now, what if I would have selected the other one? Now, some things stay the same, but there's one huge difference. On this one, I had 87.9. On this one, I have 2.1. How can it possibly be the same answer? Now, I'm going to take the same approach. I'm identifying the sides. This is the hypotenuse. And you don't have to write this down. I'm just showing you how you would have done the other one. Okay? Because some of you would have selected this triangle. Did the function change?
No.
I'm still using the tangent function. So it's kind of interesting because these two functions look completely different. 12 tan, or tan of 87.9 equals x over 12. This is 12 tangent 2.1 equals 12 over x. So when I have x in the denominator, I just do what? Switch. X equals 12 over tan 2.1. 12 divided by tan 2.1. So this just goes to show you the ratios, even though we're doing two completely different triangles, still give me the same answer. That's the whole reason we use trig functions. Even though they look so much different, they still give me the same answer. To me, that's what makes this more interesting than anything else, because either route that you take, and some of you might even find a different way, you're still going to come up with the same answer if you do it correctly. Okay? But you're going to need to redraw the triangle so that you can set up a problem that you know how to do. It's the same thing. I'm just making sure I can see it. All right. Now, you're going to have a problem that looks like this where we don't have a picture. Okay? Okay. Now, you're going to have to draw the picture. And I would suggest you draw it as close to what you read. So a person whose eyes are 5 feet above the ground. Again, I know you're impressed with my drawing here.
Yes, please.
So this person's eyes are 5 feet above the ground. Is standing on the runway. So here's my runway. 100 feet from the control tower. So I'm going to draw a really cool looking control tower.
What if you don't know what a control tower looks like?
You can just draw a tower. So the first sentence, a person whose eyes are 5 feet above the ground is standing on the runway of an airport 100 feet from the control tower. Is that exactly what? It doesn't have to be fancy. You can draw a line or whatever. That person observes an air traffic controller in the window of the 132-foot tower. What is the angle of elevation? So remember, yesterday when I was talking about angle of elevation or angle of depression, it always starts from your line of sight. So the question is, am I looking for the angle that is here? Or am I looking for the angle that's here? From their line of sight or from the ground?
From the line of sight.
From the line of sight. That's the angle that we're going to be looking for. This one right here, this angle. Here's my line of sight. Here's my angle of elevation up to the person in the window. That's my X. Do I know how long this is?
100 feet.
Question is, what is the distance here?
80.
No.
Where did you get that number?
No, this is our X.
Oh. 127.
How did you get 127?
132 minus.
This is the length of the entire tower, but I'm looking from somebody that's 5 feet off the ground. So 132 minus 5 is 127 feet. So that's why see why I stressed drawing the picture out as good as you can. Now, it doesn't have to be perfect, but you have to remember, if I'm doing angle of elevation or angle of depression, it's always from a line of sight, from somebody or an object. Now, I'm going to treat this triangle the same way I would treat any other triangle looking for a missing angle. I'm going to identify the sides. Where is my hypotenuse? Where is my opposite leg? Where is my adjacent leg? So what am I dealing with? The opposite and adjacent, which is the tangent function. Now, because I'm looking for an angle, I'm not going to write it down like I typically did on the last problem, because when you're looking for an angle, you have to use the inverse function. In fact, if you want to tell yourself when you're studying this, when I'm looking for a missing angle, I'm using the inverse function. Now, it's not going to be tangent every time. I'm just telling you to recognize if you're looking for an angle, you're writing it down like this. And it's opposite over adjacent. Now, the good thing about these problems is I don't have to do anything else. I'm going to type it in exactly the way it looks. Second tan, 127 divided by 100. And again, I'm going to round to the nearest unit. So this is 52 degrees. That's it.
The drawing part is gonna mess me up tomorrow.
You don't have to draw.
It would help. Last part, special right triangles. Now, I didn't put any examples down because if you know the properties of them, then that is going to help you out more than anything else. So if you have a 45, 45, 90 degree triangle, you know the legs both have to be the same. So what do we put there?
XX.
And the hypotenuse?
X to the square root of 2.
Yes, x square root of 2. Now I'll get my hand out of the way. If I have a 30, 60, 90 degree triangle, across from 30 is x, across from 60 is x square root of 3.
2x.
So as long as you understand these properties, you're going to have a problem you're going to have two problems. One's going to be a 45, 45, 90. The other is going to be a 30, 60, 90. Two of those. You have a total of 5 problems on the test. Some of them have multiple parts, okay, because you have to explain different parts. But if you study this and you understand the ratios and you understand the special right triangles, you should be in good shape. I feel more comfortable about you all taking this quiz than I have any other quiz before this.
Same.
Okay? We've actually taken less time to do this than we have before. So it's two things. This is more concrete, plus you're getting more familiar with the terminology and how to work with some of these shapes, which is what we want to happen. If you were to retake the map test, some of you would automatically answer 1 or 2 more questions just from this alone. So that is what I want.